I wanted to explain the process over here a little different way. So remember, when we're looking at inverse function, f inverse of f of x over here, this is equal to x. And since f of x is x cubed plus 2x squared plus 1, this is also equal to that. So therefore, we can actually do implicit differentiation over here, differentiating the left and the right side, and the derivative of x is 1. The derivative of f inverse is f inverse prime of x cubed plus 2x squared plus 1 multiplied times the inside derivative, which is 3x squared plus 4x, and then solved for f inverse prime of x cubed plus 2x squared plus 1 by simply dividing. So we end up with f inverse prime of x cubed plus 2x squared plus 1 is equal to 1 divided by 3x squared plus 4x. So when we're wondering whether we should plug in x or y, we can clearly see that this is the y value for the original function over here. Now we can see on the right side, we have the x values corresponding to that same original function. So if we're plugging in an x value of our original function, that corresponds to the y value of our inverse function, and which in our case was -1. So we have to plug in -1 in order to solve this, which is 3 times -1 squared plus 4 times -1, which we found earlier was 1 over 3 minus 4, or -1. So when we're looking at the formula above, where it says the derivative of the inverse function of x is equal to 1 divided by f prime of f inverse of x. So f inverse of x takes us back to an x value, because the inverse takes our y back to our x. This is why we have to plug in x for method 3, even though we plugged in y values for method 1 and 2 of the original function, or an x value of the inverse function. So I hope this helps.